Hi again. We're getting into some mathier stuff we can do with ice tables, and here we have a system. It's all one-to-one, which is nice, and they give us the amounts of the reactants that are put into a vessel at the beginning. Now, I've been warning you for a little while that they're going to start giving non-1 liter vessels, and it finally happened. If you want to get this one right, you have to put in concentrations for the stuff we started with, and that means concentration is N over V. So the number of moles, which they gave us, divided by the volume, which is 2 liters. So for SO3, we get 0.300 divided by 2 is 0.150. Exact same thing for nitrogen monoxide. And as usual, they didn't mention NO2 or SO2, so their concentrations are 0. And in questions like this before, they'd give us an equilibrium number and then we'd do our accounting thing, but they didn't do that this time, so that's new. How do we handle this? Well, math people, when they don't know what's going on, they call something X and see if they can make some progress that way. So if some of this SO3 reacted and we don't know how much, we could say this change was minus X. These things are one-to-one, so this will be another minus X. These are also one-to-one, although they're being produced instead of used up. So here we could say plus X and plus X. And now we have enough to fill in our equilibrium row, kind of. This is 0.150 minus X. This is the exact same. 0 plus X is X, and 0 plus X is X. So now we have something at least. And these are all tied together because they make the equilibrium constant, and they told us what that is. It's 0.15. So if we write our K formula, for products, we get X for NO2 and X for SO2, and I'm going to write that as X squared to save a little bit of room. And for reactants, we have 0.150 minus X, and that happens twice. So we get 0.150 minus X all squared, and they told us that equilibrium constant is 0.5. Okay, so is this something we can do math to and get a value for X maybe? Let's see. There's a couple of ways you can solve this, and in general, if you're feeling wobbly on the math, I would say get a graphing calculator, graph this side as your y1, this side as your y2, and then you can use the intersection function to find the solutions to this. That's the least stressful way. But if you want to finesse this, the fact that these are both squared means we can square root our left side. And that's okay to do as long as we also square root our right side. If you do that, it'll strip that square off the numerator and that square off the denominator. And then your next line will look like X over 0.15, I'm dropping that 0, minus X equals the square root of 0.5, which is 0.707, I forget, 7071. Now, if we want to solve this, we have an X in the denominator, which is bad. I want to get that out of there, and so I'm going to multiply both sides by the denominator, 0.15 minus X. If you do that on both sides, on the left, the 0.15 minus x's here cancel, leaving us with just x. On the right, we get a bit of a mess, 0.7071 times 0.15 minus x. This is outside the bracket, so it distributes through. It's going to multiply the number and the x, and so we get x equals, times 0.1061, 0.1061 minus 0.7071x. We want all our x's on one side, so add 0.7071x to each side, and you get 1 0.7071x, because you had 1x plus this number. 1 plus 0.7 makes 1.7. And that equals 0.1061. Then divide by 1.7061 and you get, sorry, I keyed that wrong, 0.1061 divided by 1.7071. X is 0.062. Now that we have that, we can go back to the ICE table and plug this number in everywhere. Anywhere that there's an X, we now know what X is. It's 0.062. So the NO2 concentration would be 0.062. The SO2 concentration, also 0.062. The sulfur trioxide would be 0.150 minus 0.062, which is 0.88, 0.088. And exact same thing for the NO. Right? A little bit of a slog, but the same setup. The ICE table does the same job it always did. It's just we had to do a little more work on the end to find our equilibrium numbers. So it's nice if you don't have to do this X thing, but if you do know how to do it, you can solve stuff that wouldn't be tractable otherwise.